Welcome, Geometry students, to the help video, page 168, numbers 1 through 33. Let's go ahead and get started with this cumulative review. Here we go, chapters 1 through 3. All right, number 1, describe a pattern in the numbers 10, 12, 15, 19, and 24. Then write the next number you expect and the pattern. Okay, let's see if we can't find a pattern here, students. We have 10, 12, 15, 19, 24. Well, it looks like to me we added 2 to the 10 to get 12. And we added 3 to the 12 to get 15. Then we added 4 to the 15 to get 19. Then we added 5 to the 19 to get 24. So the best assumption I can come up with is we're going to add 6 to the 24 to come up with 30. Okay? All right, moving on to number 2. Show that the conjecture, and by the way, let me go back to number 1. There's really no system I can give you, no step-by-steps to use, no certain way to do it. You just have to kind of look at the situation and try to find a pattern. Okay. Number 2, show that the conjecture is false by finding a counterexample. The square of a number is always greater than the number. Well, that sounds good. 2 times 2 is 4. 4 is greater than 2. 3 times 3 squared is 9, and 9 is greater than 3. 4 squared is 16, and 16 is greater than 4. But hold it, how about 1 squared? 1 squared is 1, and 1 is not greater than 1. There's one counterexample. How about this? 0 squared is 0, and 0 is not greater than 0. So there's a couple counterexamples right there. Okay? The square of a number is not always greater than the number. All right, moving on. Name a point, number 3, that is collinear with points A and D. Now, collinear means they lie in the same line. So here's A. Here's D. It looks like B. A, D, and B all lie on the same line. So, name a point that is collinear with A and D. That would be point B. Number 4, name a point that is not coplanar with A, B, and C. Now, here's A, here's B, and here's C. They all lie in this flat, paper-like plane. Okay? But if you look, here's like a piece of paper with a pencil being jabbed or stabbed through the paper, and T's down here on the tip of the pencil. T does not lie in plane M. And notice that points A, B, and C lie in plane M. And T does not. Coplanar means lies in the same plane. So I want a point that is not coplanar, or in other words, a point that does not lie in the same plane with A, B, and C. And that would be T. T does not lie in the same plane with points A, B, and C. So point T. Number 5. Name the intersection of AD and CG. All right, well, here's AD right here. There we go. And CG. Here's CG right here. Here's C and G. So line CG is right here. So it looks like they intersect right here. What point is that? Well, that's point B. Point B. Okay? And then name 2 lines that do not appear to intersect. Name 2 lines that do not appear to intersect. Well, if you ask me, pretend you have a sheet of paper right here, and this red thing that I'm coloring in is your sheet of paper. Okay? And on that sheet of paper, you've drawn a line. And it's this line right here. And then you take a pencil, pretend the pencil's a line, and you jab it through the sheet of paper so that it hits right here. Those 2 lines are never going to intersect. I mean, this line's going to continue to go on and on, going backwards. And this line here, hopefully you can picture it as going straight up in the air. They're not intersecting. So, lines AC and line D. I said DG, that's wrong, DT. Those 2 lines do not intersect. Okay, moving on to number 7. Now they want us to find the length of DE. Now the entire segment is 25, got it? And this part of the segment here is 9. So we have to find this leftover segment right here, and that's obviously going to be 16. And I got that by taking the entire segment 25 and subtracting out this segment here and coming up with 16. And another way to look at it is what number plus 9 gives you 25. 16 plus 9 gives you 25, okay? All right, number 8. Okay, the entire segment here all the way across is 16, okay? And this part right here is 5, okay? So this part right here must be 11, because 11 plus 5 is 16. Or in other words, you can take 16, that's the entire length of the segment, minus 5, which is part of the segment, and you will get 11, which is this segment right here. Okay? So the answer is 11. All right, and the last one, let's see how we do here. Once again, the same type of problem. The entire segment from P to R is 19. This part of the segment from Q to R is 12. So we must find this segment here from P to Q. Well, 19 is the entire segment minus 12, which is part of the segment, would give you 7. So PQ must equal 7 because 12 plus 7 equals 19. And there we go. Okay, moving on. Let's take a look at number 10. All right, numbers 10, 11, the directions say to plot the points and sketch angle ABC, and then classify the angle as acute, right, or obtuse. So here we go. Angle A is negative 6, 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's negative 6, positive 6. Point A. Point B is negative 2, positive 2 right here. And then point C is over 4. 1, 2, 3, 4, and up 2 right here. And let's go ahead and get our lines drawn here. And I believe, now let me say one thing, students, I forgot to mention, it's angle A, B, C, C. And it's so important that you see that because you could really draw a lot of angles. You could have drawn your angle like this. There's one angle, or you could have drawn your angle like this. There's another angle. So it's so important you see that they want angle A, B, C. And since B is in the middle like this, A, B, C, then you know you want B here to be in the middle of your angle also. Okay, now, is that angle 90? Is it less than 90 or is it greater than 90? Well, let's take a look at this real quick, okay? This would be 90 degrees right there, okay? This would be less than 90 if we swung it this way, okay? This is definitely greater than 90, so if the angle is greater than 90, then we call that an obtuse angle. All right, number 11, here we go. Point 2, 1, so over 2 up 1. And then B is over 4 and up 7. 1, 2, 3, 4, 5, 6, 7. So here's B, here's A, and then C is 10, 5. 1, 2, 3, 4, 5, 6, 7. It's going to be tough. Let's do this. Let's put all these together and slide it over a little bit. Here we go. And now let's see. We want to go over 10. 1, 2, 3, 4, 5, 6, 7. 8, 9, 10. So over 10, then up 5. 1, 2, 3, 4, 5. So over 10, up 5. So right here. Okay, so remember they want us to draw angle A, B, C. That's what that's what the directions say to do. So since B is in the middle right here, then we want B to be in the middle of our angle. So we'll go right here and draw this, and we'll go right here and we'll draw this. Now, students, please listen to me. Yes, it definitely looks like it's 90 degrees. It does. Okay, I understand that, but you cannot go by what it looks like. Okay, you have to be careful. Now, remember, we know something here, and we've talked about this, about lines that form a right angle. Okay, we've talked about this. If they truly form a right angle, then their slopes, remember, their slopes will be opposite reciprocals. Okay, so let's find the slope. If this is truly a right angle and these two lines are truly perpendicular, then their two slopes will be opposite reciprocals. Okay, so here we go. Let's check this out. It looks like the slope of this line here would be, let's do rise over run. So the slope of this line right here, line AB, we draw a triangle going over and draw a triangle down and find the rise over run. Well, the rise is 1, 2, 3, 4, 5, 6. So the rise is 6. And the run is 1, 2. 2. So rise over run is 6 over 2. So the slope the slope of AB is 6 over 2. Remember, you read it from left to right. So here's the left part of the line over here. Here's the right part. It's going upward from left to right. So it's a positive slope. And it's a positive 6 over 2. So a positive 6 over 2 would be positive 3, because 6 divided by 2 is 3. So the slope of this line here is 3. Now, let's do the same thing over here to this line. Let's do rise over run. So here's your rise. Here's your run. Okay? Now the rise, you start here and count up. The rise is 1, 2. So the rise is 2. The run is 1, 2, 3, 4, 5, 6. You start here and you count when you move. So 1, 2, 3, 4, 5, 6. So there we go. The slope of this line is rise over run. And notice this. Notice how the line is sloping downward from left to right. Here's the left side of the line. Here's the right side is going downward. So it's a negative slope. So if you reduce that, you get negative 1/3. Now I have a question for you. What was the slope of this line over here? Positive 3. What's the slope of this line over here? Negative 1/3. Well, I have two questions for you. First of all, are the signs of the slopes of these two lines, are the signs opposites? Yes, they are. One is positive and one is negative. Now, are they also reciprocal? In other words, are they flipped? Well, 3 is the same thing as 3 over 1. And if you flip 3 over 1, you get 1/3. So, do the two slopes have opposite signs? Yes, they do. Are the two slopes reciprocals of each other? Yes, they are. So these two lines are perpendicular. And if these two lines are perpendicular, then we know this angle right here is 90 degrees. So we would say this angle is angle ABC is a right angle. Okay? Hope that made sense. It's a pretty tough problem. Okay, moving on to number 12. Okay, line L bisects AB. That means it cuts it in half. Okay, so AB is cut in half. So if AB is cut in half by this line here, and the distance from C to B is 29, then we know the distance from A to C is also 29. Now find the length of AC. Okay, we just did, no problem. AC is 29. Now find the length of AB from A all the way to B. Well, that would be 29 plus 29, so 58. The main thing they're reviewing here is when a line bisects a line, the line that's doing the bisecting cuts it in half, okay? All right, number 13, same thing with an angle bisector. KM is a bisector, so KM is cutting this big green angle in half. Okay, right there. Now students, if this ray MK or KM is truly cutting this angle in half, and this angle here is 41 degrees, then we know this angle right here is also what? 41 degrees, so we can definitely say that 2x plus 7 equals 41, okay? Now subtract 7 from both sides, and you're left with 2x equals 34. And then divide both sides by 2, and x equals 17. Okay? So again, what they're reviewing there is what a ray does to an angle when it bisects and it cuts the angle in half. And by the way, I could also ask you, what is the measure of the entire angle all the way across? Well, if this is 41 and this is 41, then the entire angle LKJ would be 82 degrees, 41 plus 41, okay? Number 14. Okay, now think about this, students. The whole angle here is what? 90 degrees. That's the whole angle, right? So what that tells you is if you take this angle here with one dot and this angle here with two dots and you add them together, they better equal 90. So I can say 2x plus 3x equals 90. And of course 2x plus 3x is 5x. So 5x equals 90. Divide both sides by 5 and x equals 18. All right, let's take a look at number 16, or number 15, excuse me. Now number 15, look guys, you've got to learn to recognize these. We have a line here with a line coming off of it like this, okay? Whenever you have a line, a straight line with a line coming off of it, these two angles here are called linear pairs. And remember, we've learned this, linear pairs are always supplementary. So if they're supplementary, that means if you add them together, they equal 180. So I can take this angle here with one dot and this angle here with two dots, and I can add them together, and I should get 180. So 2n plus n plus 15 equals 180, because these two angles here are a linear pair, they're supplementary. Well, 2n plus 1n would be 3n equals, bring your 15 over and make it a negative 15, 165. Now divide both sides by 3 and n equals 55. Okay? Not too difficult. All right, let's continue on. Let's take a look at number 16. Now, we have learned in the past that vertical angles are equal. That means when two lines intersect, this angle here, this angle here with one dot, and this angle here with one dot are these two angles are congruent, and this angle here with two dots, and this angle here with two dots, these two angles here are congruent. Okay, we've learned that vertical angles are congruent. And when do you have vertical angles? When two lines intersect, the angles that are across from each other are vertical. So really, if this angle here is 30 degrees, then this angle over here is also 30 degrees. So we can say that 3x equals 30. Divide both sides by 30, or divide both sides by 3, excuse me, and x equals 10. Okay? All right, moving on to number 17. Rewrite the statement in rewrite the statement in if-then form. Then underline the hypothesis and circle the conclusion. Intersecting lines are coplanar. Okay, if two lines intersect, then they are coplanar. Or you could say then they both lie in the same plane, because coplanar means lies in the same plane. Now students, next they want us to underline the hypothesis. We're going to do that in green, okay? If two lines intersect, that's your hypothesis. And they want us to circle the conclusion. Now the conclusion is always the then part, okay? So if two lines intersect, that would be your hypothesis. Then they are coplanar, that would be your conclusion. Okay? All right. Number 18. Okay, they want us to work on our properties now. And remember, we have symmetric, transitive, reflexive, addition, subtraction, multiplication, division, all these types of properties. All right, so let's start off with number 18. If xy is congruent to yz, then yz is congruent to xy. Now, first of all, they just swap places. Okay, so make sure you see that, students. Look, xy, yz, over here we have yz, xy. So what they're saying is, it's really basic. If xy is congruent to yz, then yz is congruent to xy. Whenever that happens, we call that the, I'm forgetting the word, the symmetric property. Now, Listen to me carefully, students. It's either the symmetric property of congruence or the symmetric property of equality. Well, look, do we have equal signs here or do we have congruent signs? Well, congruent. So we call this the symmetric property of congruence, okay? All right, number 19. If the measure of angle P equals Q and Q equals R, then P equals R. So P equals Q, Q equals R, thus P equals R. Well, guys, we call that transitive. You really should have these memorized, students, okay? Transitive. Now, would it be the transitive property of congruence or the transitive property of equality? Well, look, do we have equal signs here or do we have congruent signs? Well, we have equal signs, so we call this the transitive property of equality, okay? All right, number 2. If AB equals CD, then, look, we subtract 2 from both sides. We subtract 2 from AB and we subtract 2 from CD. So, if AB equals CD, then AB minus 2 equals CD minus 2. We call that the subtraction property of, and we're dealing with equal signs again, so subtraction property of equality. Okay, you really got to know these, students. Okay, make sure you're familiar with these properties. Okay, moving on. Sketch a figure that best fits the description. Okay, here we go. Line K is perpendicular to line J, so we can quickly draw that. Okay, line K line K is perpendicular to J. So there we go. J, K. And line H is parallel to K. Okay, no problem. So line H is parallel to K. There we go. K is perpendicular K is perpendicular to J. H is parallel to K. So an arrow here and an arrow here. All right. Okay, number 22. Line W lies in plane D, and line V is skew to line W. Okay, so here we go. If we can figure this out. First of all, let's draw our plane here. We have plane D, so can I draw it going backwards a little bit here? Try to give it a little depth perception. So there we go. We call this plane D, so we'll put a capital D down here. Now pretend this is a sheet of paper and I took a pencil and I drew a line on the piece of paper. There's the line I drew, and that's line W. Okay, so line W lies in plane D and line V is skewed to W. Now what that means is, that means V will not intersect W, but it also does not lie in the same plane. That's what skew sorry, excuse me, students. That's what skew lines mean, okay? It means they do not intersect and they do not lie in the same plane. So if V is skewed to W, it doesn't intersect it, and it also is not going to lie in the same plane. So I'd put a line here. It's very similar, students, to a pencil being stuck through a sheet of paper, okay? And we'll call this line V. There we go. Those two lines are skew. Those two lines will never intersect, but we don't call them parallel because they don't lie in the same plane. Remember, parallel lines never intersect, but they lie in the same plane. Skew lines never intersect, but they don't lie in the same plane. Very big difference. Very important you understand that, okay? Okay, number 23. This is going to be really difficult, so watch carefully. This is going to be really hard to do. This will be very challenging for you guys. Okay, name 4 pairs of corresponding angles. Okay, here we go. 4 pairs. Well, first of all, angles let's see, angles 2 and 4 are corresponding, and 5 and 10. Now let me show you how I knew that. Okay, please watch carefully, students, how I did this. Okay, watch. I'm going to take this line here, BD. I'm going to make it a little longer than usual, okay? And I'm going to take this line here and make it a little longer than usual, like this, down through here, okay? I'm going to make this line here a little longer than usual. And I'm going to make this line here a little longer than usual, like that. Okay, now I'm going to slide this out of the way first. Well, I better put the angles in here real quick. So this is angle 2, this is angle 4, this is angle 5, and this is angle 10. Now it's really hard to see this unless, students, you learn to pull bits and pieces of the drawing out. Let me show you what I mean. Look what I've done here. I didn't keep the entire drawing. Do you see that? I just kept certain lines. Now look, this is so obvious now that I've done that. Look, here's a line cut by a transversal. Are not these two angles here corresponding, 2 and 4? Sure they are. 2 and 4. Are not 5 and 10 corresponding? Sure they are. So 5 and 10. Now we have two more sets to find, okay? They want us to find 4 pairs or 4 sets. So here we go. Let's see if we can't do that. 2 and 4, 5 and 10, 1 and 7, and 4 and 9 are also corresponding angles. Let me show you how. Okay, 1 and 7 and 4 and 9. And it's going to be the exact same thing again. Okay, watch. I'm going to take this line here and extend it. Take this line here and extend it. Okay. Then bring this line down like this. And then bring this line down here. And this is angle 7. This is angle 1. This is angle 9 right here. And this is angle 4. I'm going to pull the picture away and watch this carefully, okay? Look at that. It's so obvious. Once we take part of the picture and just keep part of it. Look at this. Here's 2 lines cut by a transversal. It's obvious this angle here and this angle here are corresponding. So 1 and 7, and it's obvious we have 2 lines being intersected by a transversal here. So angles 9 and 4 are also corresponding. So 9, 4. Okay. All right. Let's continue on. So that's a pretty tough problem to see there, but hopefully you guys can see that. Okay. All right. Let's continue on here. Let's flip this up, and here we go. AC is parallel to DE. Let's turn this, guys, so that our parallel lines are horizontal. Okay, so they're telling us in number 24 that AC right here is parallel to DE. Okay, so these 2 lines here are parallel. All right, the measure of angle 2 right here, this angle here, is 55. Okay, and they want us to find the measure of angle 4. Now, no, I'm sorry, they want us to find the measure of angle 6. Okay, so this angle right here. So I could, now listen to me, students, I could draw this line here, but why would I do that? The angles I'm dealing with are angles 2 and 6, so there's no need to draw that line. Angles 2 and 6 are over here on this line, so I'm going to draw this line here. And you say, well, Mr. Earhart, I don't have a mimeopad. How can I do this? Put your sheet of paper on top of this and just trace the lines that you need so you can see it a little better. If I gave you a problem like this on a test or a quiz, you would want to put a notebook paper over your test or quiz and just trace the lines that you need, and then lift your paper up and it will look like this here. Okay, now let's get the angles written in here. I did forget to do that. So we're dealing with angles 2 and 6. So this is angle 6 right here, and angle 2 is 55 degrees. Let's pull this out of the way now. There we go. Now, students, look. This line here, they told us, is parallel to this line here. And it's cut by a transversal right here. Okay, now I should have totally gotten rid of this line here. I'm not sure why I left this line in here, but anyways. Okay, this angle here and this angle here, they're called alternate interior angles. And what do we know when two lines are parallel cut by a transversal? We know the alternate interior angles are congruent. So if this angle here is 55 degrees, then angle 6 is also 55 degrees. Okay, let's continue on. Let's take a look now at number, whatever would be next here. Let's see, number 25. Now they're saying to us that BD is parallel to CF. Okay, so let's grab this, let's turn it so that our parallel lines are horizontal. Okay, so BD and CF. Okay, there we go, back to normal. All right, now they're telling us that BD, let's get rid of that real quick. Okay, they're telling us that BD right here is parallel to CF. Okay, now we're dealing with angle 2 and angle 4. So here's angle 2 and here's angle 4. So really the only side I need to trace would be this side right here. Okay, now angle 2 is 55 degrees. I'm going to put 55 right here. And then the measure of angle 4 is right here, so I'll put a 4 right here. Now, let's move this picture out of the way real quick. And students, look at what you have. Whenever two lines are parallel cut by a transversal, these two angles here are called corresponding angles. And you definitely need to know that. Well, we know that when two parallel lines are cut by a transversal, corresponding angles are congruent. So the measure of angle 4 equals 55 degrees. Okay, students, boy, hopefully it's real important you're seeing this, okay? I hope that you understand this. All right, let's take a look at number 26. Number 26 says, if the measure of angle 3 plus the measure of angle 6 equals 180, then which lines are parallel? Now look, students, think about this. Think, okay? We're dealing with angle 3 and angle 6. Well, those are the two angles that should be on the transversal. So BD's your transversal. Well, guys, if BD's your transversal, then the two lines it's intersecting would be this line here and this line here. Now that helps a lot, okay? Now let's do this. Let's pull this over here for a second, okay? Let's go like this, and let's turn this thing around, okay? Now, they're telling us that angle 3 plus angle 6 equals 180. Thus, what they're saying is angles 3 and 6 are what? Supplementary. Now, we had a theorem that said, listen to me guys, if two lines are cut by a transversal so that the consecutive interior angles are supplementary, then the lines are parallel. So, we know that 3 and 6 are consecutive interior angles. We know they're supplementary. So this line here is parallel to this line here. Okay, let's pull this back down here real quick here. And where's angles 3 and 6? Let's turn this around here. I think I have 3 and 6 turned around, which is no big deal. I'm just saying. Alright, here we go. Okay, and then we'll slide it down a little. That's good enough. Yeah, my fault. This would be 6 here, and this would be 3. But either way, they're still supplementary. Now, which two lines are parallel? Well, this line here and this line here, they're the two lines that are cut by a transversal in such a way that the consecutive interior angles are supplementary. So, this line here and this line here are parallel. Now, what are those lines called? Well, let's see. They're called, sorry about that, they are called line DE and line AC. So, there we go. So, lines DE and AC are parallel. Okay, look that over, back it up, and watch it again if you need to, but make sure you understand that when two lines are cut by a transversal in such a way that their consecutive interior angles are supplementary, those two intersected lines are parallel. Okay? Okay, moving on to number 27. Okay, numbers 27, 28, and 29 conclude whether you have enough information or whether you don't have enough information to decide whether the two lines M and N are parallel. Well, look guys, we have two lines cut by a transversal. This angle here is congruent to this angle here, right? Those are called alternate interior angles, and we know that when two lines are intersected by a transversal in such a way that the alternate interior angles are congruent, then we know for sure that the two lines are parallel. So yes, we definitely have enough information to state that M is parallel to N. Yes, we have enough information. Why? Because alternate interior angles are congruent. Now, number 28. Guys, we don't have any information. Can I show you something real quick? Watch this. I'm going to draw this line here and this line here. Okay? Now, this angle here is congruent to this angle here. Now, I'm going to take this line here, like this, and watch what I do to it. I'm going to take this line here, and I'm going to move it up a little bit. Well, it probably won't let me. Okay, that's fine. Well, what I was going to do is I was going to take it and kind of move it. It's not going to work. But what I was going to show you is this. I was going to say, look, just because these two angles here are congruent, vertical angles, doesn't mean this line here is parallel. I mean, I could do this, guys. I could draw a line like this and a line like this and state that this angle here is congruent to this angle here. That's totally true. And then draw another line like this. Well, there's no way that this line here and this line here are parallel. There's no way. But yet, these two angles are still congruent. So we do not know for sure if M and N are parallel or not. So, no, we don't have enough information. Okay, look, here's how you know if the two lines are parallel. Either you have alternate interior angles congruent, we don't have that, or alternate exterior are congruent, or corresponding angles are congruent, or consecutive interior angles are supplementary. We had none of those four scenarios, okay? Number 29. Now this one looks like we might possibly not have enough information, but we really do. Can I show you something, students? Watch this, please. You got to think outside the box. Okay, here's M. Here's N. Now I'm not going to draw this line here, okay? I don't really care about that line. I'm going to draw this line right here. Now watch this. This is so cool. Watch this. Now this angle here is 60, okay? 60. Now this whole angle here from here to here would be made up of two little angles. This angle here with one dot is 60, and this angle here with two dots is also 60, right? We can see that. So if I wanted to find the whole angle from here to here, I would add the two angles together and I would get 120. So this whole angle here is 120. Now I'm going to slide this out of the way and watch what I have. Look at that. Now watch, students. I have two lines cut by a transversal in such a way that what? What do we call these two angles? They're both on the right side of the transversal. They're both interior angles. We call those what? Consecutive interior angles. And what did we learn? Anytime that two lines are intersected in such a way that the consecutive interior angles are supplementary, then the two lines are parallel. And students, the last time I checked, 60 plus 120 is 180. So these two angles here are supplementary. So the consecutive interior angles are supplementary. Thus, these two lines are parallel. Okay? All right, let's take a look here. What do we have? We have parallel lines. I'm going to take this object here, excuse me, this picture, and turn it so that my parallel lines are horizontal. It's always easier, students. Learn to do that if you can. Okay, so here's my parallel lines right here. And now this question is dealing with angle 1 right here. So let's go ahead and draw this line here, okay? Okay, angle 1 right here is 35 degrees. They want us to find the measure of angle 2, which goes from here to here, that whole angle. So, again, students, I know that you don't have a memo pad, but you do have a sheet of paper that you can put over this in your book, and you can turn your book so that the two intersected lines are, or the two parallel lines are horizontal, and you can copy this, trace this onto your notebook paper. And now look what we have. See this red arrow right here, students? And this red arrow right here, we know these two lines are parallel. And when two lines are parallel, cut by a transversal, these two angles here, this angle here with an X and this angle here with an X, those two angles are called consecutive interior angles. And we just looked at this on the last problem. Remember? Consecutive interior angles are supplementary. So these two angles here are supplementary. That means they have to add up to 180. So if this angle is 35, then I take 180 minus 35 and I get 145 degrees. There we go. So this angle right here, angle number 2, is 145 degrees. Okay, pretty cool. Moving on to number 31. Okay, let's take this again and let's turn it so that we have our parallel lines horizontal. So there we go. Good enough. And here's my two parallel lines right here. Okay. Now we're dealing with angle 3 and angle, let's see, angle 3, which is right here. And they tell us the measure of angle 3 is 40 degrees. Okay, there we go. Let's pull this. Well, let's number our angles. This is angle number 1, angle number 2, and that's good enough for this problem. Now, here's their question. The measure of angle 3 is 40, which is right up here. Name another angle that measures 40. Well, guys, right here, look. Anytime we have two parallel lines, and we have parallel lines, red arrow, anytime we have parallel lines cut by a transversal, the corresponding angles are congruent. Now, Mr. Earhart, why did you say corresponding angles? Because that's what we have. This angle here with one dot and this angle down here with one dot are corresponding angles. And you guys really need to learn to recognize those and know those right away, okay? It's very important that you do. So when two parallel lines are cut by a transversal, the corresponding angles are congruent. So if this angle up here is 40 degrees, then the measure of angle 1 would also be 40 degrees. So the answer is angle 1 also measures 40 degrees. Okay? All right, moving on to number 32. Okay, given that each post is perpendicular to the deck, explain how to show that the posts are parallel to each other. Okay, well, they want us to explain how these posts here are parallel. So if I'm going to be dealing with those two lines and proving they're parallel, I'm going to turn this so that those two lines, my two potential parallel lines, are horizontal. So there we go. All right, now, here's what it says. Given that each post is perpendicular to the deck, so here's the deck right here. Here's the post. Here's the other post. Now look what it says right here. It says each post is perpendicular to the deck. So I know I have a right angle here and a right angle here, okay? How do I know for sure that the posts are parallel? Well, students, we learned this earlier in the chapter. We learned that when two lines are perpendicular to the same line, those two lines are parallel. So how do I show that? I would just say the two posts right here. I'm going to highlight them for you. This post here and this post here. The two posts are what? They are perpendicular to the Same line. And here's the same line they're perpendicular to right here. Okay? So these two lines here are perpendicular to the same line, thus they're parallel. That's a theorem or a postulate, I forget which one it was, that we learned that said if two lines are perpendicular to the same line, then they're parallel to each other. Okay? Students, that's it. I hope this cumulative review has been a help to you. Please make sure you're really studying this and understanding what we've covered so far. And if you have any questions, don't hesitate to call or email.